Welcome back, friends. So we have been, I think, practicing. You are all practicing the sums based on various trigonometric and exponential, logarithmic, differentiation, come integration kinds, and then sincerely preparing for the examinations. I feel in the last class, I remember we have completed integration by parts, and then a special type of sums connected with e to the power of x inside f of x plus f dash x will be there. Such sums also we have completed. So wherever you are finding this integration special functions related sums, you should always remember the formulas, standard formulas. Once again, there is no requirement for you to derive all this one. For example, root of x square minus a square integration is there. Already we have done by taking substitution. Suppose when you are encountering this particular standard root of x square minus a square in your sum elsewhere, while resolving a particular sum, once again there is no need for you to resolve this, solve this sum from the beginning. Just you can put the formula as it is, the solution as it is. Okay. So please remember all the standard formulas. Today we are going to touch a very important topic called as definite integral. Definite integral examination point of view most important. So let us understand first what is this definite integral meaning, and then we'll do a very few fundamental sums on this. Then we will go to the properties of definite integrals. Today I will be able to do some sums on the definite integrals and then definition of the definite integral. Let us go to the whiteboard. Yeah. So today we are going to do the definite integrals. Very easy, in fact, but very important, and you should remember properly. So once you use the word definite, what does it mean? It means that there is a unique answer for your integration. You know very well, so far you have done integral f of x dx kind of sums. So many sums you have done. Let us say this is equal to f of x plus c. Okay, you are writing c also. Here, this f of x is not a definite answer for you, where x belongs to, let us say, real numbers. So any value belonging to the real numbers may satisfy this equation. So you are not giving a unique answer to me for this. The function is defined, let us say, for a long interval, like set of real numbers means minus infinity to plus infinity. So that time what happens, the solution can be infinite. Any number can come over there. If you specify my boundaries are like this for this function, so f of x is called a function here. This function is defined in a particular xy plane starting from origin to, let us say, end of it, 0 to infinity, like set of all natural numbers. Then out of all these natural numbers, if you define the function only for a particular region, let us say I'll draw one example, small understanding to understand one small graph I will draw for you, so that you will be able to clearly understand what I am telling. See, this is your x, this is your y. Now you defined a function like this. Now this function may be going like this. Let us say it is going like this. We are not bothered how it is going, where it is going. Infinitely it is going. Now I will define my function between these points. Let us say between a and b. Only between a and b, I want to study this function. I want to find the integral of only this region. That time I should just say that I have defined boundaries for my function. A and b are called as the limits of this function. A is called as a lower limit, b is called as the upper limit. Towards the positive side we are traveling. So remember this point, always b is greater than a. Okay. Now, if the integrand means, I think you know, this is called integrand. If integrand is defined between a given interval, say a comma b. Like this, I have closed it. Remember, this is square bracket long back. I told you clearly, if the bracket is given like this, a comma b, that means interval is open in both sides. Except a, b, all other numbers are included. In this case, if you write like this, a and b are included. In this case, a and b are not there. It's open. Okay, open means I mean to say not included. Within AB, all numbers are included. I'm sorry, again I'm repeating. If the interval, if the brackets are like the small brackets, your function will take values only between A and B, not A and B. It will not include A and B. Whereas if you give a square bracket, that means A and B are also included in the function. So right now I have given this bracket. So my function will have now A as the lower boundary, lower limit, B as the upper boundary or upper limit. So like this it will come. So what did I do in this case? I am telling that I am only defining my function within this. So if I integrate this and put these values in the final value of the integrand, in integral, then I will be getting area under the curve. This is the curve defined. So this shaded region, whatever I am shading here, will be the area under the curve between, let us say I will define like this, A and B, 2 points on this curve. And you draw perpendiculars to the x-axis, so that anyway these are the intervals. This is the lower limit, upper limits, both you will get. So that means after integrating, I will get like this. Now I will be putting A comma B, sorry, A and B. So I have to apply now these values. According to the fundamental theorem of calculus, first we have to put the b in the place of x. F of b minus sign we have to put f of a. So this is called as the value of this integrand or definite integral value. This is called as the value of the definite integral. So f of b and f of a are the values of this function at a and b. Okay, so when we are doing our sums, we will come to know that clearly. So, but we should know that this will give us area. This shaded region is going to give the area under this curve. Please do remember that. This is called fundamental theorem of calculus for us. Now, let us first work out one or two sums, then only you'll come to know. All the rules of integration, whatever we have applied so far in the previous exercises, will apply here in the same manner. There is no difference, there are no new set of rules. Only some theorems, properties of different integrals will be there, which we will work out after understanding. Integral, these are all from NCERT textbook I have taken. Integral 2 to 3 x square dx. Simple sum. So x square dx, you know very well, it is called x to the power of 2 plus 1 by 2 plus 1. And limits we have to apply 2 to 3. So what is the answer now? This is first x cube by 3. When you apply the limits, first we have to apply the upper limit to the x. So that will become 3 cube by 3 minus 2 cube by 3. This is your what we call fundamental theorem of the calculus, f of b minus f of a, what we learned in the previous page. Okay, let us see now what will be happen. 3 cube means 27 by 3 minus 8 by 3. 27 by 3 is nothing but 9 by 8 by 3 here. So 3 into 9, how much? Here itself, without that you could have done this sum. Okay, 19 by 3, shall I write? Over, no, sum is over. 27 by 3 minus 8 by 3, 19 by 3. Why unnecessary waste of time doing all this? It's not required. Done. So our answer is, just check again. 19 by 3, 27 by 3 minus 8 by the 27 minus 8, 19 divided by 3. This is the first sum. Let us take up the second sum. Integral 1 to root 3 dx by 1 plus x square. See, now straight away, this is nothing but tan inverse x. It's a formula from our standard integral formula. Dx by 1 plus x square integration, if you carry out, you'll be getting tan inverse x. So what are the limits they have given? Boundaries. Lower limit is 1, upper limit is root 3. So that means first we have to apply the tan inverse root 3 minus tan inverse 1. Tan inverse root 3 is nothing but tan 60 degrees is how much? Root 3. So tan inverse root 3 is equal to 60 degrees. Under radians, I'm writing here pi by 3. The value of tan inverse root 3 from trigonometry is pi by 3. Tan inverse 1 is nothing but pi by 4 because tan 45 is 1. Tan 45 is 1 and the tan 60 is root 3. Therefore, tan inverse of 1 is called 45. Tan inverse of root 3 is called pi by 3. What is LCM for 3 and 4? 12. So 3 will go 4 times 4 pi. 4 will go 3 times 3 pi. So pi by 12. This is the answer for this. Let us see the third sum. No problem. All are easy sums here. But only thing is we have to carefully do. That's all. Integral 0 to 1 x e to the power of x square dx. So by seeing this method of substitution, this is coming under, put x square is equal to t. Now here what happened? We have transformed the sum from x variable to t variable. So x variable is connected with the 0 and 1 as its boundaries. By changing this x square to t, whether limits can be write 0 to 1 or anything else we have to write, we have to check now. So first check the lower limit. Put x is equal to 0. Lower limit in the given sum is 0. So what will happen that time? 0 square is equal to t. Therefore, t is equal to 0. So lower limit after transformation is 0 only. Again, upper limit of this, put x square is equal to 1. Then 1 square is equal to t. So t is equal to 1. That means our limits 0 and 1 did not change. So what is this called as? Limit changing. This is called what? Limit changing. We are changing the limits, but luckily both match to same. In some cases it may not. So 0 to 1. Here, after putting x square is equal to t, differentiate both sides. What you will get? 2x dx will become dt. Is it not? So x dx will become dt divided by 2. So here x dx place is there. That will become dt by 2 e to the power of t. Because x square value we can write t. So your sum becomes like this now. So 1 by 2 is right outside. Integral 0 to 1 e to the power of t dt. So now you write down e to the power of t means integration t. Half is outside. We should not forget half. 0 to 1. Substitute now. First upper limit, then minus sign, lower limit. Upper limit in the place of t1, lower limit is 0. So half outside again. E to the power of 1 is e. E to the power of 0 is not 0, it is 1. Please remember. So this is the sum over. Let us go to the next sum. Integral 0 to pi by 4 sine cube 2t cos 2t dt. In this case, we have to take again method of substitution. Which one will take? Put sine 2t is equal to u. Then differentiation of sine 2t will become cos 2t. 2t differentiation 2 and dt is equal to du. Okay. Then we can write down here 2 cos 2t 2 cos 2t dt is equal to du. or cos 2t dt is equal to du divided by 2. This is about the differentiation. Now limits. Limits also we have to change. First, what is the substitution for us? Sin 2t is equal to u. What is lower limit? 0. So t is equal to 0. First we have to put. So sin 2 into 0 is equal to u. So sin 0 is equal to u. So sin 0 means 0. So lower limit became 0. What about upper limit? Sin 2t is equal to u. Sin of 2 into pi by 4 is equal to u. 2 will go 2 times. So sin pi by 2 is equal to u. Sin pi by 2 means 1. So 1 is equal to u. So our limits. Lower limit is 0. Upper limit is 1. So our sum transformed to now integral 0 to 1. Then u cube, sin cube tt becomes u cube. We'll write down clearly this sum. Correct? Yeah. Integral 0 to pi by 4 sin cube 2t cos 2t dt has become now integral 0 to 1 u cube dt by 2 du by 2. Sorry, this is not du because you are differentiating u function, sorry, integrating u. So this will become now du by 2. So bring this half outside. 0 to 1 u cube. Okay, half is outside. U to the power of 4 by 4, 0 to 1. So half into 1 to the power of 4 by 4 minus 0 to the power of 4 by 4. So this become 1 by 2 into 1 by 4. 1 by 2 into 1 by 4. That means 1 by 8. So do remember, these are all very, very easy sums. But transformation of limit when you are doing carefully, you should apply and do knowledge. So next, I think we have to go to the properties of different integrals, which I would like to take up in the next class. So children, you start preparing well for examinations. Keep revising. This only will help you as a brush up knowledge. You can 20 minutes videos, you can see them and understand basics. That's all. Thank you so much.